In this lesson, we're going to learn how to graph systems of inequalities. Yesterday, we learned how to graph inequalities, but the fact that it's a system just means that there's more than one. So we're going to look at how different lines, parabolas, circles overlap one another. The most difficult part today will probably be the shading. All right, so there's a lot of things that you probably already know how to do just looking at this first example. First off, you know how to graph this because it looks like y equals mx plus b. Secondly, you know that this is a dashed line instead of a solid line because it's just a less than sign. The below graph is going to be a solid line because it's a greater than or equal to. So if it has that or equal to part, it's solid. If it's just a less than or just a greater than, it's a dashed. Okay, so let's just sketch this one first off. We know this starts at 1 on the y-axis, and then it has a slope of 2. And I know it's going to be dashed, so that's what it should look like. All right. Next up, I have this equation. It's written a little funny. It's actually point slope form. So I know it has a slope of 2/3, and the point is going to be -2, because remember, it's always the opposite of what's in parentheses, comma, -4. So if I go to that point, -2, -4, and I go up 2/3, I should get the solid line right here. So I color coordinate them for you. All right, now I have to figure out how to shade. Okay. So I know for this green graph, y is less than 2x plus 1. So that means everything below the dashed green line is going to be shaded. So everything under here. That was beautiful shading, wasn't it? All right, and then for the bluish graph, it's y is greater than, which means everything above the blue line is shaded. So here it is, really beautiful again. Okay. The part that we care about though is where the shading overlaps one another. And so it may not be obvious from my terrible drawing, but it's right in this section. It's this V right here. So I'm going to use pink because pink's my favorite color. This is the final answer. This whole section. And then everything in it too. All right, the pink section is the final answer. So what I actually would suggest you do, I would highly recommend you use a pencil while completing the homework. So you're going to shade one section, so I shade the green section, and then you're going to shade the other section blue. And wherever they overlap, that's your final answer. So now use your eraser and erase everything else. So that's what I'm going to do. I'm going to erase all the stuff outside because it looks like this could be the solution based on how I drew it. So I'm going to erase everything outside. So it's pretty obvious with my terrible colors that it's just this little V right in here. Okay, and it extends forever and ever. That's my solution set. All right, let's do another example. All right, so let's see. I know the green one's going to be solid line, and the pink one's going to be a solid too. Okay, so I know that much. Now, this is not written in y equals mx plus b form, so I could change it, or I could do x and y intercepts. So the way that works is if you just cover up this term, so I'm covering up the whole y term. If 3x is equal to 24, then what does x equal? Well, x equals 8, right? Now if I do it vice versa, if I cover up the x term and just look at the y, what would make this equation true? Divide by 4, y would be 6. What that means is the x-intercept from back here is 8, and the y-intercept is 6. So when I draw that line, on this x scale, I can find 8. On the y scale, I can find 6, and just cross them to one another. Let's try it again. So I'm going to cover up the y term. So if 5x equals 20, well, x equals 4. And if I cover up the x term, notice I still have that negative on here. What would make this true? It'd be -10, because you divide both sides by -2. So I like to just use my finger and cover up one of the letters that I don't need. So I said the x-intercept was 4 and the y-intercept was -10. So if I go to 4 on the x scale, -10 on the y scale, I can get my line right there. All right, let's address the awful shading that's going to ensue now. Okay, well, unfortunately, it's not very easy to solve for shading when it's not written as a y equals or y is less than, y is greater than. So the method we learned yesterday in class is plug 0, 0 in. If you can plug 0, 0 in and figure out if it works or it doesn't, then you can decide which of the sides you're going to shade on. So if 0, 0 works, that means I'm going to shade all of this stuff over here. If 0, 0 doesn't work, I'm going to shade everything over here on the green graph. So plug 0, 0 in. So I would get 0 plus 0. Well, that's 0. Is 0 less than or equal to 24? It is. So that means 0, 0 works. So that means I have to shade on this side of my green graph. There it is. Okay, let's try the same strategy for the pink graph now. Plug 0, 0 in. 5 times 0, 0. 2 times 0, 0. 5, 0 minus 0 is 0. Is 0 less than or equal to 20? Yes, it is. So that means 0, 0 works. So of my two sides of the graph, you have kind of this left upper and this right lower. We're going to shade on this side of the graph. So all up here. Okay. Up here too, down here too. Oh, that's just beautiful. All right, so the last step now is to take my eraser out, okay? I'm going to erase wherever the pink and green didn't overlap. So green was just here by its lonesome, so that doesn't count, and pink is over here by itself. So my final solution is this really kind of triangle, not really triangle shape of all this junk over here. So I erased everything that doesn't overlap with the other color. Make sense? All right, let's try it again. All right, so I have this nice blue graph and the pink graph. All right, so the blue graph, I could do y-intercepts, x and y-intercepts, excuse me, but I would rather just change it into y equals form. So what I'm thinking is I'm going to move the y over here to make it a positive, and I'm going to move the 6 over here. So if you need to pause the video and understand how I get this equation, feel free to do so. I did not show my work. But this is the final equation because y is on this side now, so y is less than. And this sign is very important. Okay, well, I can graph that really easily because it has a y-intercept of 6 and a slope of 2. Oopsies, you didn't see that. That's the next graph. Moving on. That's my blue graph, and it's a dash because it's not or equal to. Oh, hey, look, there's a parabola. That's what this one is. This one is a parabola, and it's shifted left 2 because remember, plus means the opposite side, so it's going over this direction. So I know it's over here at -2, and then I just sketched a couple dots. I know it's up 1 over 1, up 4 over 2 kind of thing, but it's really a sketch, so don't worry about that part. Oh, also it was dashed because it was just greater than. Okay, so now I can do my shading. So the blue graph, the y is less than. Notice that I'm using my new equation now because this one won't work because it's not a y equals form. So this one is going to be less than, so underneath the blue graph. Because if you can take any point on the graph and just go down, that's the side you're going to work on. It doesn't matter where you take it. So this entire section here. There we go. Beautiful. Okay, next the pink graph. This one is greater than. Okay, now it's kind of weird because we haven't done greater than or less than on a parabola yet today. So it's the same concept we just talked about the line. If you take any point, so I'm going to take this point because that's my favorite point on the graph, and just go up, because greater means up, that means the inside of the parabola is getting shaded. Or maybe easiest is if you take the vertex. You took the vertex and you go up because it's greater than, that means the inside of it is being shaded. So everything in here, there we go, inside the parabola is shaded. Okay. Last step, I'm going to take my eraser and erase all that gorgeous work I just did. So anything that's just blue or just pink is going to get erased. So it's kind of a fun little shape when I'm done. So there's all my blue gone. And let's get rid of all the pink. They overlap and make that weird dark blue color there in the middle. Can you see it? It's this little U right here. That section is where they overlapped, and that is my final solution set. Let's try another one. All right, so this yellow graph. Oh, what graph is that? That is a circle. And what is the radius of that? Because you know x squared plus y squared equals r squared. That means r is 3. So this is a circle with a radius of 3. Okay, so I'm going to draw that on there. So see if it appears. There it is. So it's centered at the origin and goes out 3 every direction. Okay. This is an absolute value, which means it's a v, not a u, and it's shifted down 3 because of that -3 on the end. So normally it'd be a V going through the origin, but we're going to shift it down 3. So I got that graph. Okay. I completely forgot to tell you, of course, these are both going to be solid lines because there's that or equal to on both equations. So that's probably what I would do first. If you're trying to think of like a step-by-step process, step 1 is what kind of lines you're going to draw. And maybe make a little note off to yourself over here, right? Solid or dashed, okay? And then go ahead and sketch it in, and then make sure you double check that you sketch the right type of line. All right, so once you have the lines, then the next step, so I guess step 3 would be shading individually. So let's shade the yellow graph. The yellow graph is, again, I can't really solve it this way. So what I need to do is I need to plug 0, 0 in. So if I plug 0 squared plus 0 squared, that's 0. Is 0 greater than or equal to 9? No, it's not. So that means this dot right here, 0, 0, is not in the shaded section. So that means it's all this stuff around here. Oh, it kind of looks like a sun. That's pretty. Okay, pretend that's a pretty sun. So it's everything on the outside of the circle. All right, now the pink one. So this one I can just do the up or down because it's just in y equals form. So this is y is greater than this whole equation. So it's going to be everything above the line. So take a point on the line and go up. That works. Point on the line, go up. Yep, up, up, up. So everything in this V works. Let's do it here. There we go. Beautiful. All right, so then I think we're on step 4 if I didn't lose count. Last step is we're going to erase anything that's not overlapping. So there's no pink down here, so we're going to get rid of all this yellow. Okay. And then there's no yellow in here, so I'm going to get rid of all this pink. So this is kind of a cool looking graph. So I just have, it's almost like fire coming off the sun. I have this semicircle, and then the lines coming off it. All of this is shaded in here because the pink and yellow overlap one another. All right, I think I just have one more. Let's try it. Okay, so this first one's pretty easy because it's the exact same graph as last time. It's a solid line. Okay, step 1, solid line. Step 2 is just a circle with a radius of 3. So I'm just going to sketch it all over again. There it is. Okay. The next one is a solid line, and it's a V. It's an absolute value. This negative means it's flipped over the x-axis. So normally it's going to look like this, but I'm going to flip it upside down. And then the plus 3 comes afterwards, which means I'm going to take my upside down V and shift it up 3. There it is. That's what this one should look like. Okay. Step 3 is to shade. So let's shade the pink one first. This time I'm going to plug 0, 0 in. So I get 0 squared plus 0 squared, 0. Is 0 less than or equal to 9? Yes, it is. So that means 0, 0 works. So I'm going to shade everything inside this beautiful circle here. Oh, that's just gorgeous. Okay, next up is the blue graph. This time I don't have to do the 0, 0. I could, but I'd rather not. And I know it's less than or equal to. So I'm going to be shading everything inside the V and below because you take a point on the graph, you go below. Point on the graph, below. This is what's shaded down here. So everything here is shaded. You guys wish you could be a teacher just for the painting. So fun. Okay, so last step, step 4, is erase. So let's see, I see some pink up here that didn't get any blue, so I'm going to erase that. I'm trying to make it look pretty. Erase that pink, and then obviously there's quite a bit of blue down here because I got a little crazy. I'm going to erase all of that junk. So my final graph is this weird looking thing. I got a line here, and then like almost a semicircle or so right there. That is the only part that is shaded for my final solution set. All right, so that is your lesson. Go ahead and complete assignment number 6, students. Good luck.